First of all, welcome to this webinar, and I would like to start by thanking Global PropTech, Walter Schupino and Derek for giving me the opportunity here to share with you how we see digitization going across every stage of a building life cycle. And maybe first, just to position Spacewell. We are part of a large group that is listed on, has been stock listed since 1999, part of the Nemetschek group, and the group represents 16 software brands which are all building related. Nemetschek is also the instigator or the inventor, I would say, of the Open BIM standard. And we're organized across 3 divisions that really cover the entire life cycle of a building. And on the next slide, you see that representation a little bit better. From left to right, you see the 3 phases of the life cycle of a building, from planning and design, over building and construct, to operate and manage. And then at the bottom, you see those 16 software brands, which might sound more familiar to you than the Nemetschek name itself. In planning and design, you might recognize, or you might have heard of, for example, Graphisoft and Vectorworks. I'm sorry. In building construct, we have Allplan, we have Nevaris, we have Bluebeam. And then at the bottom right, you see Spacewell. We operate in the operate and manage phase. So that third division, or the third part of the life cycle of a building. And we believe in the industry, we're really at a pivotal moment, which is why we call it the amazing world of the building life cycle. And the reason for that is, I believe this industry has had a very heavy reliance on manual labor, on mechanical technologies, on fairly traditional business models. And as a result, productivity across this life cycle has stagnated, or I would say has evolved very slowly. If you compare that, for example, with the automotive industry, they have seen enormous productivity increases over the last decades. The automotive industry not only has been an early adopter of technologies like, for example, robotics, which you see here, but also embraced different technologies that optimize supply chain, has been early adopters of very intelligent quality management standards. And also, because of the very competitive nature of that industry, is forced to really look ahead. And you can also see the automotive industry performing strong there with things like autonomous driving, and also with a shifting focus, I would say, almost away from the car and towards the driver. Even thinking of concepts like hospitality, safety, of course, the well-being of the driver. In the building construction or the AEC industry, we've been, as I said earlier, slower in adopting a number of these practices, but I believe we're at a tipping point, or at a pivotal point, where we can really make benefits of those new technologies. And we believe that when we rethink about innovation in this sector, we really need to do it across the entire life cycle of the building and optimize across those phases that I was showing earlier. Another reason for doing that and for taking a holistic approach is that in that third phase, the operate and manage phase of a building, that is where 80% of the cost is. Intuitively, that is not something people always realize, but it is definitely the case. And there are multiple reasons that are causing that, which you can see at the bottom here. The first one is data loss, and I will zoom in on that in a moment. The second one is the complexity triggered by the fact that you have many different stakeholders, many different companies being involved in the different life cycles of the buildings. There's cost as the result of bad design. There is cost as the result of reactive maintenance. Typically, maintenance is never on time. It's either too early or it's too late, but it's never just in time, as in, let's say, the manufacturing industries. I think very topical in these COVID-19 days is how we deal with unforeseen usage, overcapacity and undercapacity of real estate portfolios typically points to an overcapacity across the planet, but particularly in the Western world, we see that about 50% of buildings are unoccupied. So now that people start returning to the office, what is the usage going to be? How do you deal with that fluctuating usage? And how do you make sure you don't oversize your portfolio? So that's a big driver of cost. Then there's a lack of convenience for the people in the building. And last but not least, very static, typically static facility management schedules, fixed times and intervals for example, cleaning. So in this webinar, what I will try to explain is how we believe we can tackle, at least that is our objective or my objective for this call. How can we tackle these causes of cost? And if we think of the answer, it's not only data. It is not only it takes more. And what I believe it takes is really a holistic approach across the building life cycle, which covers a number of components, which will allow facility managers and real estate managers, and I believe we will have a number in the audience today, to tackle the challenges that we had on the previous slide. Now, until now, BIM hasn't been very successful in crossing over to the managed phase of the buildings. Again, you see here from left to right the different phases of planning, design, constructing, and typically what you have is that you have, as you shift from one player to the other, you have a loss of data. And if you're looking at the point of handover to the managed phase, you get to an asset information model, which includes the graphical data, the non-graphical data, and the documentation. Like I said, built up over different steps, over different suppliers to that model, with data loss, and then typically also after handover, as owners change or as renovations in the buildings happen, we tend to see a data loss. So this is obviously not the picture that we want to see. We want to see, or I think we all share an objective where we actually prevent that data loss, not only from the planning to the design to the construction phase, but also after the handover to the managed phase, where actually, as we continue to use the building, that we grow and enrich the information that we have there, which then allows us to start correlating the intelligence and the data we have, and to start really building intelligence that allows us to act on that information. And that then really forms the basis for what we call a digital twin. Some of you might think that the whole concept of the digital twin has become a bit of a hype, and I think we've all seen and heard many definitions of what the digital twin is. What I think we will agree on is that it is definitely more, or it should be more than just a digital representation of a physical object. That's kind of the first step. But that is not where it stops. A true digital twin also allows you to simulate and analyze what has happened to that building in the past. And on top of that, it optimizes what is happening now in the building in real time, so that you can move from looking back at what happened to a building, that you can start anticipating and looking forward what will happen in a building. So the data gathering alone is not enough. And if we then again think of how we should look at holistically the life cycle of a building, then we believe there are two phases to add, one at the left and one at the right of this picture, in order to make it that full circle from design to construction to manage. If I start on the right, kind of the next phase or the next step up from efficiently managing a building is really to manage it remotely. If you have a digital twin, it allows you at the speed of light to intervene through technology, through systems, with the interventions that are needed in that building. And we see good examples of that in other sectors. For example, physical security, I think, is a good example where remote operation centers have been established for a long time. Myself, I've been working in IT for most of my life. Large IT companies, managing of infrastructure is typically done remotely. So there is no reason why those principles and technologies and processes cannot be applied to our industry. Where it really becomes interesting, we believe, is that with the data that you store, that you build, that you gather during the life cycle of a building, also after handover, once it is used, is that you can create a feedback loop back into the design, which architects tend to call parametric design. And if you think of the fact that if we project forward to, let's say, 2040, within 20 years, then the current estimates are that 80% of the buildings that we will have in 2040 already exist today. So the amount of retrofitting that is going on and that is still going to continue to happen is enormous. The cost involved in that as well. So if you can do that in a clever way with real-time data, with accurate asset information models, you can make, I'm sure you will agree, that parametric design much, much better and much more future-proof. Now, in order to do that successfully, again, I believe we need to add a number of parameters. And again, this is something you will hear me coming back to a couple of times, but it's really about more than just the data. I think the whole focus on the digital twin and the BIM models tends to be too data-driven. You need to enrich that with other perspectives. The one that you see in the square at the bottom right is people feedback. That is the subjective element that we need to inject into the model, and that is really crucially important. Remember what I said earlier in the automotive industry, the shift going from the car to the user experience. We believe the same really needs to be done in our buildings, in our office buildings, to make sure we accommodate for the health, the well-being, and the productivity of the people that work in that building or that visit that building. The other one is real-time data ingestion. Today's IoT technology, Internet of Things technology, allows you at a low cost with a low price threshold to really deploy sensors in buildings that allow you that real-time data ingestion. And then on top of that, kind of the icing on the cake is a workflow engine, a brain, if you want, that takes in that correlated data, the real-time data, and starts steering the interventions that need to be done in that building. This is also where, at a later stage, clearly the concepts of artificial intelligence and even machine learning can come in to more efficiently manage a building based on that digital twin that we can then manage and operate remotely. So another way of looking at the different layers in which you can build a digital twin, and I'm showing this to kind of demystify the concept, is to start from, let's say, the inside of the onion with the asset information model that I think you know, on which you deploy a good level of master data management. And then again, you can, across the three phases, planning, building, and operating the building, you can start expanding and move to the different subcomponents of that, where obviously you do your additional planning, you do your structural analysis, you move to your tendering phase typically before you start building. Then you have the different phases within the budgeting and planning part of the building, and then the ultimate building itself. This is where we propose you inject also the multi-year maintenance planning and budgeting for the building. More and more construction companies are asked not only to calculate the price of building or executing the building project, but also to commit to long-term total cost of ownership of the building over 10, 20, sometimes 30 years. So that multi-year maintenance planning is an important one. And then we move to the execution of the operate and manage phase. So this is another way of looking at the different data layers that you have around the asset information model at the core. And then we have some recommendations and attention points that help you to come to that level of building intelligence, the remote operations center, and then satisfying that user experience. So how do you make that succeed? And I'm going to speed up a little bit on this one to make sure I stay within the allocated time. But we believe, as in any data model that is at the core with your asset information model, you do need to make sure that the classification of the buildings and the components within the buildings is really super important in order to drive the design for cost decisions. And that needs to include, from the very beginning, room classification, which is typically not done today. But we believe that we need to stretch and push that forward and already do the room classification at the earliest stage of the building life cycle, moving obviously to quality control, things like class detection, which I think you will be familiar with, the maintenance planning that I talked about earlier, making sure the BIM model stays alive and is updated with data in real time from the construction site, where mobile technology these days allows that. The industry for a long time has been really very much paper-based. We believe that step needs to be taken within that building phase to use mobile technology to update the data, the forecasting of the maintenance budget that I mentioned earlier, making sure the asset information model remains updated for future maintenance tasks. And then, like I said, capturing after commissioning with building management system sensors and IoT sensors data for that parametric design into your next cycle of refurbishment. Speeding up this in your project initiation means obviously you need to focus on building the right master data and having a strong information model. That's really the core of the digital twin. And then moving across the design collaboration, the project management, again, keeping an eye on the total cost, making sure you take into account smart maintenance, doing work preparation using BIM models and IoT-enabled comfort monitoring, to the smart workplace, which, like I said, drives that focus, that improved and increased focus on the safety, well-being, and productivity of the people that are working in that building, or that are delivering services to that building, or are visiting that building, allowing then the real estate managers and the facility managers to better manage the buildings, the portfolio, and the utilization of the portfolio that I was talking about earlier. So designing and taking that holistic view, we believe, addresses those reasons for cost, that 80% cost that you have in the maintenance phase of the building that I was talking about earlier. Then coming to the closing of my pitch here, I want to stress the philosophy of the Nemetschek Group being a very open one, so we can support these different phases and these different components of the digital twin model with our own 16 brands that we have within the group, but we are also open to work with solutions from other providers and other architectures. Which then bring us to what we believe are these benefits of the building life cycle. So rather than having data loss, this approach gives you accurate and up-to-date data that stays up to date. We believe this approach is going to reduce the communication issues, misunderstandings, data quality issues between the different stakeholders working on the building, increasing the efficiency and increasing the well-being of the employees that are there. So I think with that, I think I was able to stay within the allocated 20 minutes. And I hope I've convinced you that taking that holistic approach can address the challenges that we have in the industry and can drive the innovation that I think will launch us into the next and a very exciting era for this industry. So I would like to thank you for your attention, and Derek, I guess this opens us up for questions. Thank you very much.
Yes, thank you very much, Eric. We did have a question that came in. This one: can you offer remote FM software if you use the holistic digital twin model?
Can we offer remote facility management software? I think it's a chain of solutions. Maybe I need to double check that I understand the question correctly. But by taking the steps that I just described, we can basically allow indeed a combination of having a remote operations center and then having on-site services that are being delivered. So let me give a couple of examples. If you think of that workflow engine that I was talking about earlier as kind of the brain, and you have the IoT-enabled building or the smart building as the body, then indeed through remote actions, using networks, using IT technology and software, you can do remote interventions. But I don't think a remote operations center concept necessarily needs to go that far. If you take a first stage of doing remote monitoring, and that is something you can do perfectly using the connections and the data feed that you get from the building management system or from the IoT sensors, that can also trigger more traditional work orders for facility management personnel who can then do a physical intervention. So I think there is a hybrid model that you can use in combination with the remote operations center. You have the current way of working, you have the remote operations center, you can do remote interventions using the technology that I described, but you can also trigger on-site interventions using typical facility management information systems or CAFM systems, if that answers your question.
Perfect. Thank you, Eric. I have another question as well. So using the digital twin throughout the life cycle of the building is a very valuable tool, especially if you're looking at new construction where you can start at the very beginning and have a complete history of the information that's involved through to the operations and maintenance. But what about for existing buildings? Is it applicable to come in, say, after the handover and to build up a digital twin model for an existing building and use that moving forward?
Yes, definitely. Thank you. That is a very good question. So you don't need a full-blown BIM in order to initiate a number of these concepts. So at Spacewell, what we do with many clients is that we actually start from just a 2D CAD drawing, which we start loading into our systems, and you can start enriching the data from there without necessarily having a full-blown BIM model. So this is one of the reasons why I kind of showed the different layers of that onion. If you remember earlier in the presentation, in that concentric circle, you don't need everything in order to apply those concepts. So like I said, you could load floor plans into the systems, you can do your space management on that, you can then add your sensor data, your real-time data that you capture. And many of the buildings that we currently turn into smart buildings by applying IoT concepts to them are projects that we do on existing buildings that don't have a BIM model. It's perfectly possible. So the wireless technology allows you to make a building smart without drilling holes and recabling a building. It's, like I said, a very low technological and also financial threshold to make an old building smart. It's not an issue.
Okay, perfect. And another one, early in your presentation, you mentioned that real estate is very manual, labor intensive. It would seem to accomplish all those pieces in the pie chart. It would seem to be able to accomplish all those pieces in the pie chart would be as well very labor intensive. AI doesn't seem to be advanced enough to capture all of this. Can you comment on that?
I agree that if you look at the entire building life cycle, then it will also in the future continue to be very manual and mechanical by the nature of the size of what we're making. Yeah? So typically you have in your planning and design phase a digital model, which you then turn into the physical reality in the build phase. And then if you compare across sectors, things don't get much bigger than a bridge or an office tower than anything else. So for that reason, I do agree that there are limits to what artificial intelligence or IT technology can do. There will always be a very strong, heavy physical element in this industry. But the reason why I kind of challenge the level of innovation and speed of innovation that we've applied in the sector is because there are a lot of processes that support that work that will always be physical that are still very, very much paper-based, and as a result are not accurate, tend to be out of date, give data replication issues, data quality issues. So I would say if you separate the supporting processes from the hardcore building work, then the room for optimization is in all these supporting processes, and there will always be a physical core that you cannot fully automate. I agree on that. So there's a boundary there somewhere, but I do believe there's still a long way to go in further optimizing and increasing efficiencies.
Perfect. And one more question here. Do you use open BIM principles?
Yes, we do. So thank you for that question as well. The philosophy that we have within the group is really an open philosophy. And like I said, the Nemetschek Group has really been the instigator or inventor of open BIM. And we believe that is the way forward, because we do want to break down those silos between those different players. We do want to optimize data exchange and automation holistically across the life cycle of the building. And one of the ways to take down those barriers is to make sure that you don't have proprietary systems, proprietary data standards, but that you have open standards. So that's really at the heart or at the core of our DNA, I would even say.